Hello everyone, good evening. This is Shambhavi, your physics master teacher. Hope all of you are doing good. How are you all? If my audio is clear and video is clear, please let me know in the chat box. Good evening everyone. So let me just check in my phone as well. So just give me a second with the audio. Yeah, I think audio is also clear. Yes, I am good. So hope you're also good too. Just let me know if audio and video are clear. I hope it is clear. Yeah. So, in today's session, okay, so the today's plan is to start up with, one shot revision session for your upcoming first test. Okay, so we'll be starting up with chapter 1 today, that is units and measurements. Okay, so soon we'll move for, chapter wise we will go, keeping in our mind that very soon you're going to have your first test. Okay, so our main idea of these revision sessions is your upcoming test. Okay, so we'll quickly go through all the concepts. We'll have a quick revision. So that's what all these one shot lectures are meant to be. So we'll quickly go through all the chapters, all the topics in the given chapter, and we'll also take up some problems, some questions, like maybe 2-mark questions, 3-mark questions. So that way also we will divide, so that question practice will be in one session, and one short revision of entire chapter will be in one session. So that is the plan. Okay. Yes. Yes, Sunita. Hi. Am I audible? Hope you're following. Kindly respond if some of you are there, and so that it gives me motivation to go ahead quickly. Okay, so as I said, today topic will be units and measurement. Okay, so in today's class we are going to discuss about units and measurement. So in this units and measurement we can actually broadly classify into two subtopics. One is about the units, how do you measure, what are the different types of physical quantities. Okay, so that is one concept. The other one is about the dimensional analysis. Okay, how to write the dimensions, or basically what is a dimension, and then how to get the dimension of a physical quantity, and what are all the uses of this dimensional analysis. Okay, so that can be the broad classification of this chapter. So we'll quickly start with the units first. Different types of units, physical parameter means what. Okay, so first we'll begin from that, and then we'll move on to dimensions. Okay, so first of all, so we are having a concept like, a term like physical quantity, correct? So what do you mean by a physical quantity? Can someone respond in the chat? Yes, Sunita, thanks for your response. Now I saw your message. Yeah. So what do you mean by a physical quantity? So in physics, or in our day-to-day life, okay, why just to say like physics, in our day-to-day life, we will be coming across with measuring, many quantities, right? We will be measuring, many things. Like it may be a time. I have to go from my home to school or college. So what do? Like how much time it takes? How much is the distance, correct? So we think of all those quantities. So in physics, we say anything that can be measured and expressed in terms of numerical value. Okay, so I should be able to express in terms of some proper number. It's not like, okay, some imagination, okay, this big, or this small, this small. No, it should be properly expressed in terms of some numerical value. So such quantity we call it as physical quantity. Okay, so this is how we define a physical quantity. Okay, so if I say there is a physical quantity Q, so it should have some numerical value. So let us say N, and we'll soon come to know that if I had to express some physical quantity, some unit is necessary. So we can say like some NU. Okay, so any physical quantity can be represented as NU, where N is its numerical value or size. Let us say something like 100 kilometer, 100 meter, 10 seconds, 20 seconds, whatever may be the quantity. And U is the corresponding unit, like seconds, hour, meter, kilometer, whatever it may be. Depending on the quantity, we will have different units. Okay, so this is about physical quantity, and some simple, examples like length, mass, time, speed, energy, force, temperature, current, etc. can be mentioned. Okay. Hope all of you are following. Yes, Naveen, hi. Hope you are doing good and following this session. So it's like almost a 1.5 hour to 2 hour session. So I hope, if you listen thoroughly for this 2 hours, let us say, so you can able to, get most of the concept in this chapter. So I wish and I want you all to attend from the starting to the end of the session. Okay, so you will also, able to recollect entire chapter in a small duration of time. Okay, is that fine with all of you? So please respond now and then in chat box also, so it gives, an idea that you're following. Okay. So moving ahead, so we understood, okay, there are something called as physical quantity, and now we can, classify the quantity into two categories basically. One is fundamental quantity, okay, the second one is derived quantity. So fundamental, the name itself is telling us, right? Fundamental means something very basic. So sometimes we call it as base, base quantities. Okay, so it's very basic, such that I cannot able to express these quantities in terms of any other quantities. Okay, for example, let us take a simple one like mass. Okay, so in mass, okay, am I able to express mass in terms of any other quantities? No, mass is one of the fundamental quantities, right? So how much mass is there for a given amount of substance? So that is a fundamental quantity. Okay, yeah, but if I come to some quantities like speed, let us say, so this can be written in terms of some other quantities, right? Speed is like distance by time, but again, distance is something like length, correct? Yeah, distance by time we say speed means. So but that distance is nothing but a physical parameter, which is length, right? So we can further express these, quantities like speed in terms of other quantities. Okay, they are called as derived quantities. Okay, so what do we say? They are called as derived quantities. The physical quantities which can be expressed in terms of fundamental quantities are called derived quantities. Okay, and fundamental quantities, and they are independent with each other. So you one the fundamental quantity, you cannot able to write in terms of other fundamental quantity. Okay, or any other quantity I can say. So they are called as fundamental quantities, and I hope you know how many fundamental quantities are there. Can someone respond? It's a very basic chapter, right? Yes, someone please respond. How many fundamental quantities are there? I think. Yeah, I am coming to angle, solid angle. Okay, and also that MLT dimension notation. Yeah, I will come to that part as well. Okay, just have, just wait for a few, some more time. I will come to that part as well. Okay, I think, what's your name, actual name? Matrix Kali Yuga. What's your actual name? Can you post your doubt with the proper names? And yes, Naveen, for you as well. So I'm going to come to the dimensional notation as well. Okay, yeah, hope it is clear till here. But I asked you a question, how many numbers of fundamental quantities are there? I think I didn't get any response. So let me tell you, there are 7 fundamental quantities plus 2 supplementary quantities are there. Okay, so 7 fundamental quantities, 2 supplementary quantities are there. So let us quickly have a look. What are all those? Okay, before that, let us also, because what we have defined as 7 fundamental quantities, that is in terms of SI system. Okay, so before that, let us little have a idea about units and different types of system of units as well, and then I'll come to those 7 fundamental quantities. Okay, so now coming to something called as unit. So what is a unit? Unit is again, it's a fundamental block kind, I can say, correct? Yeah, which can be used to represent any measurement. It can be considered as a standard measurement, the basic quantity that is used to measure some big amount. Okay, the standard reference which we use to measure any physical quantity. Okay, so that is nothing but unit. Okay, the standard measurement which we use to measure any physical quantity, we call that as unit. Okay, unit of that physical quantity. So here again we have 2 different types of units. One is fundamental unit and the other one is derived unit. Okay, so yavudu the fundamental units and derived units. Again the name itself is telling us. So what is a fundamental unit or a base unit also we can say. So the unit of fundamental physical quantity, we call it as fundamental units. The units of derived physical quantities, we call it as derived units. Okay, is that clear? The unit of derived physical quantities are called as derived units, whereas the units of fundamental physical quantities are called as fundamental or base units. Okay, derived units, you can also say like these units can be written in terms of fundamental unit notation. So that way also you can define. Okay, just as we have defined fundamental quantity and derived quantity, same way we can define fundamental unit and derived unit. Okay. Yes, Soumya Prakash. Yeah, I hope I'm including some Kannada and English explanation. So if at all you need more in terms of Kannada or some particular point or at some particular topic, if you didn't get the explanation in terms of English, please let me know so that I can again go in Kannada, or if you don't understand Kannada, let me know so I can explain again it in English. Hope that will be fine. Soumya. Yeah, and I think there is one more answer. Internationally accepted reference for standard to measure a physical quantity. Yes, exactly. That's the definition for unit. It is the internationally accepted reference, correct? So that is also an important word, because I say, okay, this is my reference to measure, length. Let me say this as 1 centimeter, correct? If I consider this pen length as 1 centimeter, nobody is going to agree with me, right? Because it should be standard, universally accepted. Okay. So everywhere you go, it should be accepted and it should measure the same value. So that is what is your unit. Okay. To avoid all confusion, like, in India, we say something as 1 centimeter. If you go for any other country, if they say something else as 1 centimeter, so that doesn't make any sense, right? So in order to avoid all those confusions, we are following an internationally accepted standard reference. Okay, that is our unit. So coming to system of units. Okay, so what do you mean by system of unit? So it's a set of all the base units and derived units. Okay, complete set of both the base units and derived units are called as system of unit. It includes all the types of units. Okay, So we just have listed all the units, and that is representing a system of unit. So here, in the case of system of unit, okay, there were many and there are many as well. Okay, so there are many system of units. So in the earlier time, okay, in the earlier time, not presently, still it is there, but not so conveniently or not oftenly used. Okay, so in the earlier time, we had something like CGS system, one of the system of unit. Then we had something like FPS system, and then we had something like MKS system. Okay, CGS, FPS, and MKS system. Okay, so ಇಲ್ಲಿ CGS system ಅಂದ್ರೆ ಏನು? So CGS system andre again idu simple is a representation. So here C stands for centimeter, G stands for gram, notation is G, and S stands for seconds. Okay, so centimeter, gram, second. So this is our CGS system. So ಇಲ್ಲಿ centimeter andre enu? So we use the centimeter to measure the length, okay, gram to measure the mass, and seconds to measure the time. Okay, yes, FPS stands for foot, pound. It's more oftenly used in Britain. Okay, foot, pound, and second. Okay, so somebody asked what is FPS stands for. So FPS stands for foot, pound, and second. Again, where this foot is for length, pound is to measure mass, and second is to measure time. Okay, so that is one. And then we have MKS system. MKS system. So MKS system andre again simple. So illi length is measured in terms of meter. Okay, and then kg for the mass, and seconds for time. Okay, so length is measured in terms of meter, mass is measured in terms of kg, and time is measured in terms of seconds. So that is our MKS system. Okay, is that clear? Any doubts? Yeah, I think I have got some response in the chat box as well. Foot, pound, second, mass, kilogram, second stands for MKS. Yeah, so these are the earlier used 3 system of units, which is the name itself is very much evident. Okay, so but presently, internationally accepted system is the international system of unit. Okay, so yaudide international system of unit. So it is widely, it is defined by the International Bureau of Weights and Measurement and accepted all over the universe, all over the globe, we can say conveniently. And if I say kg in India, it will be equal to 1 kg in India is equal to 1 kg in Britain, or you go to US or any other countries. Okay, so it's a standard reference unit. Okay, so this is a French equivalent word. Okay, so international system of units is the currently accepted unit, and it is abbreviated as SI unit. We simply call it as SI unit. Okay, in ಹೇಳ್ತೀವಿ SI unit, which stands for International System of Unit. Okay, so in SI, as I already told you, like there are 7 base quantities and we have 2 supplementary units. So ಏನಿದೆ SI system ಅಲ್ಲಿ ನಮಗೆ 7 fundamental quantity or base unit ಇದೆ. Quantity means the physical quantity and units are the unit for those physical quantity. Okay, 7 base unit irutte and 2 supplementary units irutte. So which are those 7 units? So first physical quantity nodona, mass, length, time, temperature, current, luminous intensity, and amount of substance. So these are the 7 fundamental quantities. Okay, so corresponding to these fundamental quantities, we have 7 fundamental units. So mass is measured in kilogram, represented by kg, length in meter, represented by m, and time in second, represented by s. Temperature is measured in Kelvin in SI system. Make sure it is Kelvin and not degree Celsius or Fahrenheit. Okay, SI unit yadu Kelvin, and capital K is the representation. Okay, capital K is the representation for temperature. Small k bardre wrong. It should be capital K. Okay, so unit ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಯಾವುದೇ ಯೂನಿಟ್ ಇಫ್ ಇಟ್ ಇಸ್ ಎ ನೇಮ್ ಆಫ್ ಎ ಸೈಂಟಿಸ್ಟ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೈಕ್ ಕೆಲ್ವಿನ್ ಅಂಡ್ ಆಂಪಿಯರ್, ಸೊ ಅದನ್ನ ನೀವು ಯೂನಿಟ್ ತರ ಬರೀತೀರಾ ಸಿಂಬಲ್ ಯೂಸ್ ಮಾಡಿ ಅಂದ್ರೆ, ಸೊ ಆ ಲೆಟರ್ ಯಾವಾಗ್ಲೂ ಕ್ಯಾಪಿಟಲ್ ಇರಬೇಕು, ಲೈಕ್ ಕ್ಯಾಪಿಟಲ್ ಕೆ, ಕ್ಯಾಪಿಟಲ್ ಎ. ಅದೇ ಇಫ್ ಯು ಆರ್ ರೈಟಿಂಗ್ ದಿ ಯೂನಿಟ್ ಆಸ್ ಲೈಕ್ ಫುಲ್ ವರ್ಡ್ like ampere, Kelvin, then it should be small k. It should be small k here. Okay, it should be small k. Like ampere, how it is written? It's a name of a scientist. Ampere. Kelvin is a name of a scientist. So unit na full baritira andre first letter small letter irbeku, just to distinguish between, okay, I am talking about the unit, I am not talking about a name of a person. Okay, because ನಾವೆಲ್ಲ ಏನು ಓದಿರ್ತೀವಿ, ನಮ್ಮ ಹೆಸರು ಬರಿಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಲೆಟರ್ ಕ್ಯಾಪಿಟಲ್ ಬರಿತೀವಿ, ರೈಟ್? So ಅದೇ ತರ if I am talking about a person called Kelvin or Ampere, I write capital K then ELVIN like that, or ampere. But if I am saying like some temperature of 300 Kelvin, so full baribekadre small k baribeku, symbol notation baribekadre if it is a scientist name, that should be written in terms of capital letter. Okay, so ಇಲ್ಲಿ ampere anta ide, capital A ne baribeku. Okay, then luminous intensity, which is candela or CD, and then we have amount of substance, that is mole, MOLE, mole is the unit for amount of substance. Symbol is MOL. Is that clear? Any doubt? So let me just keep it neat here. Any doubts, please raise your question. Yeah, I think somebody is asking what is luminous intensity, right? Yeah, luminous intensity is like amount of energy per unit area per second. Okay, yeah, so that is your luminous intensity. Okay, so it is related to your light intensity measurement. Okay, so which is measured in candela. Yeah, plane angle and solid angles are the supplementary units. Yeah, I'm coming to that as well. Okay, so 7 fundamental quantities are done. Now we are moving to supplementary units. Okay, so which are all those supplementary units? So the quantities are like plane angle and solid angle. So their units are radian and steradian. Symbol is RAD for radian, SR for steradian. So now the question is, what is this plane angle or simply angle and solid angle? We'll move to that first. Okay, so that many of you are raising question there. Yeah, so first we'll define plane angle, or simply we call it as angle. Okay, so that is angle. You might be measuring angles from your maybe 5th standard or 6th standard. So maximally geometry start adaginda you are drawing the angles, right? So 45 degree, 30 degree, 20 degree, 10 degree, 180 degree, so ella draw madidare enu. So angle means what is the inclination between two lines. Okay, inclination between two lines ಆಗಿರುತ್ತೆ. ಇದು general definition, correct? So general definition I can say like theta. Okay, so but how can we define like a unit like an angle? Proper definition. So ಅದಕ್ಕೆ ಬೇಸ್ ಏನು ತಗೊಂಡಿದೀವಿ, we have taken a circle. So ಏನು ಮಾಡ್ತೀವಿ, ಇಲ್ಲಿ ಒಂದು ಸರ್ಕಲ್ ನ ಡ್ರಾ ಮಾಡ್ತೀವಿ. Okay, 1 second. let me try if it comes. Oh, 1 second. Yeah, so what we will take, we take a circle ಅಂದಮೇಲೆ ಅಲ್ಲಿ ಒಂದು ರೇಡಿಯಸ್ ಇದ್ದೇ ಇರುತ್ತೆ, ಕರೆಕ್ಟ್? and let us say we'll take an arc portion in that. so ಏನು ಮಾಡಿದೀವಿ ಈಗ, ಒಂದು arc portion ತಗೊಂಡಿದ್ದೀವಿ. ಓಕೆ, so this is our arc length. so usually s ಅಥವಾ ds ಅಂತ ಬರೀತೀವಿ, ಕರೆಕ್ಟ್? arc length ತಗೊಂಡಿದ್ವಿ. so ಈಗ what is the angle subtended at the center of the circle, okay, by this arc? so that is our d theta. so let me write here. so d theta ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, the angle subtended at the center. okay, so ಈಗ ಇದನ್ನ ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡಿದೀವಿ? so that is d theta is equals to arc length ds divided by the radius of the circle ಆಗಿರುತ್ತೆ. okay, ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? that angle is the arc length divided by the radius of the circle ಆಗಿರುತ್ತೆ. okay, so this is representing a part of the circle. so part of circle na ತಗೊಂಡು ಈ ಡೆಫಿನಿಷನ್ ಇರೋದು ನಮಗೆ. okay, so plane angle ಅಂದ್ರೆ is it clear? yeah, yes, if any doubts please ask in chat box. okay, I think it is clear till here. regarding plane angle, somebody was asking at that time. yes, okay. what is your full name? is it like Chinmay or something like that? it says Chinni 2K09 hash Amu. yeah, yes Navin, thanks for your kind response. okay, we will go ahead. okay, so the next thing is as I said, it's the unit of the plane angle is radian. so plane angle andre enilla, the angle between any two lines in a plane. that's the very simplest way of definition. okay, but other actual definition ellinda bandide, that is something from your trigonometry. you might have derived this last year, like in 10th standard. you may had like s is equals to r theta anta derive madirabahudu. I am not sure. you may have done this in your 10th standard in maths. okay, ಅದನ್ನ ಇಲ್ಲಿ ಸ್ಮಾಲ್ ಆಂಗಲ್ ನೊಟೇಷನ್ ಅಲ್ಲಿ ಬರಿತಾ ಇದೀವಿ. d theta is equals to ds by r. okay, yeah, so the unit is radian with the symbol rad. so radian symbol ಆಗಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಹೇಗೆ ಬರಿಬೇಕು? rad ಅಂತ ಬರಿಬೇಕು, RAD. okay, it is always remember one thing, conversion from degrees to radians. that is 180 degree corresponds to pi radians. so radians ge sometimes we put c, that will also tell you it's a radian. okay, 180 degrees pi radians, or you can say let me just write rad here itself, or 360 degrees equals to 2 pi radians, because one full circle andre 360 degree, that corresponds to how much of radians? 2 pi radians. okay, so moving ahead to solid angle. so here comes, some of you were waiting most from the beginning. so that is, what is a solid angle? so now we talked in 2 dimension like a plane angle. okay, so plane ಅಂದ್ರೆ ಏನು? ಸರ್ಕಲ್ ಇತ್ತು ನಮ್ದು. ಈಗ ಅದನ್ನೇ ನಾವು 3 dimension ಇಮ್ಯಾಜಿನ್ ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ ನಮಗೆ? so we will have a sphere, correct? yeah, you can imagine like some metal balls or the cricket balls or any spherical object you can imagine. so ಏನಾಗಿರುತ್ತೆ, in 3 dimension we will have a sphere. okay, so let me just try to draw it again. so yeah, it's just imagine like it's in 3 dimension, because when I try to draw a sphere in a 2 dimension, it appears to be a circle itself. okay, so ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, some surface area na we have to take some area, and let me say this is the center of the sphere. So now one small portion tagondo, okay, if we try to, imagine like you are cutting a portion in it. So you can imagine like a cone is being taken out from this. So imagine hege ಮಾಡ್ಬೋದು. If I take an arc portion from a sphere, this is going to give me a cone, right? So sometimes this is not so smooth while writing. So please kindly ignore the diagrams if it is not appearing neat. Yeah. So ಏನು ಮಾಡಿದೀವಿ, sphere in the ಒಂದು small cone na air portion ತೆಗೆದ್ರೆ ಏನು ಬರುತ್ತೆ, that in a 3 dimension it appears to be a cone. Correct? Everyone, you can imagine like your ice cream cone. ಹೌದಾ? ಸೊ ಈಗ ಏನಾಗಿರುತ್ತೆ, the surface area, ಇಲ್ಲಿ surface area ಏನಿದೆ, okay, so that is marked here, okay, dA, the surface area from where, from this apex point O, that is nothing but the center of the earlier sphere. Okay, so ಏನು ಮಾಡಬೇಕು, now we had to find out this surface area divided by the square of the radius. Okay, so that is going to give us the solid angle d omega. So this is omega notation. Okay, so ಏನು ಹೇಳ್ತೀವಿ ಈ ಸಿಂಬಲ್ಗೆ, omega. ಇದನ್ನ ನೀವು ಲಾಸ್ಟ್ ಇಯರ್ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲೂ ನೋಡಿರ್ತೀರಾ. ಕರೆಕ್ಟಾ? unit of resistance is omega. I mean ohm anta heltivi, notation omega. Correct? So the same thing here, omega, d omega. D omega is what? The area to the square of the radius. Is that clear? Yeah? Hope it is clear. Yes, Sunita, are you there? And Harshita is talking something else. Yes, Naveen. Hope you are there too. Yeah. So this is how we define the, solid angle. Okay. Yeah, I hope it is clear for whoever asked for plane angle and solid angle. Okay. Just imagine a cone. It's the angle at the vertex of a cone. So ice cream cone na imagine ಮಾಡ್ಕೊಳ್ಳಿ. So whatever the angle inside that vertex point or the cone, central ಇರುತ್ತಲ್ಲ, so that is a 3-dimensional angle, and that we call it as solid angle, and unit ಏನು steradian and symbol ಏನು SR. Okay, it should be very clear. Okay, fine. So thanks for your response. So I'm just moving ahead to the next concept, that is significant figures. Okay, so here again we have, it's a part of measurement. Okay, earlier there was some other concepts were there, but due to rationalization, measuring of length, mass, time, that and all has been deleted. Now we have something called as significant figures. Okay, in the significant figures ಏನಾಗಿರುತ್ತೆ, so what is a significant figure? So for just let us imagine that we are doing an experiment and I measure something. So you might have started some labs or practicals in your colleges, so where you might be doing with calipers or screw gauge, some simple measuring, right? So measure the length of some object, whatever they give, correct? So diameter measure ಮಾಡಿ, so something like that. So when we are doing a measurement, it's not that always a full number or a proper a number is going to be we are going to get. It's something like I did a measurement, let us say some length measurement. Okay, so I say something like the length was found to be in between 5.1 and 5.2. ಏನಾಗಿದೆ, I measured the length of some bar which is given. Let us imagine given to us in college. ಲೆಂತ್ ಏನು ಬಂದಿದೆ, 5.1 to 5.2 ಸೆಂಟಿಮೀಟರ್ ಬಂದಿದೆ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡೋಣ. ಏನಾಗಿರುತ್ತೆ, ಇಟ್ ಇಸ್ ಸ್ಲೈಟ್ಲಿ ಗ್ರೇಟರ್ ದನ್ 5.1 ಬಂದಿದೆ, ಬಟ್ 5.2 ಇಲ್ಲ. ಸೊ ನಾವು in our early days what we used to do, so we used to write like 5.15 or something like that, whatever second decimal we used to write, but this is wrong. Okay, so this is going to be wrong. Okay, so what we should do actually, if we are following a scientific method, so we have to take the previous one, that is 5.1. Okay, because we know that the length is between 5.1 to 5.2, but because of the limit in the given measuring instrument, because that is not giving me the second decimal accuracy. Okay, ಆಗ ಏನ್ ಮಾಡಬೇಕು, we have to write down the previous one, that is like 5.1 ಅಂತ ಬರದ್ವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Okay, so ಇಲ್ಲಿ I am 100% sure that the length is 5, but this 0.1, is it a 100% sure digit? No, that is not a 100% sure digit. We call it as an uncertain digit. Do you agree? Some doubt is also there. In some case 0.5 we round off to, but in some case we take 1. How? Could you just repost your doubt? I didn't understand. Naveen? Yeah, see, that's what I'm telling. We had to, if your question is like why 5.1 and why not 5.2, okay, when the reading is, even though if it is closer to 5.2, we had to take the previous one. Okay, that's the scientific method of measuring. We had to take the previous one, and then if you use caliper, you get the second decimal accuracy. That will be obtained from your vernier division that you do in your lab. So right now I don't want you to confuse with all those extra points. What I'm trying to say is that if in the measurement of length, it can be anything, I'm just taking the example of length like 5.1. if the reading is between 5.1 to 5.2, we had to take this previous one. Okay, and in that I am 100% sure about the length of 5 meter or 5 centimeter, let us say. In that 0.1 centimeter is not accurate. That's an uncertain to me. Okay, so here this the numbers that are reliable, okay, the numbers which are known to us properly. Reliable ಅಂದ್ರೆ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತು, ಇದು 5 ಸೆಂಟಿಮೀಟರ್ ಹೌದು, ಅದರಲ್ಲಿ ಏನು ಡೌಟ್ ಇಲ್ಲ, 4 ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲ, 6 ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲ, ಇಟ್ ಇಸ್ 5 ಸೆಂಟಿಮೀಟರ್ and plus one uncertain digit. Okay, plus the first uncertain digit, we call that as significant figures. Yeah, is that clear? So significant figure andre eno, the numbers that are known reliably plus the first uncertain digit. Uncertain digit andre enu annadakke nanu ninge ee example kottiddu. This 0.1 is not certain to me. It can be 0.1 or it is somewhere in between 0.1 to 0.2. So that's an uncertain digit to me. Okay, so the digits which are well known to me, that is reliable, plus one uncertain digit will give us the, yeah, so what we are going to get? We get the significant digits. Okay, so here it is, the reliable digit plus the first uncertain digit are known as significant figures or significant digits. So if I say like 5.1, how many number of significant figures are there? 2 significant figures. Okay, 2 significant figures. Is that clear? So this is how you will write down the significant figures. So it is all related to your measurement, how you do measurement, how to express the result. Okay, so we'll move ahead to there are certain rules in significant figures. Okay, for example, I'll give you one number like 23.54, I'll say. So what is the number of significant figures here? 4 significant figure. Okay, 4 significant figure. Is that clear? Yeah, any doubts, please ask in chat box. If you have some doubts, please ask in chat box. Yeah, so moving ahead, there's one note I wanted to tell you with in terms of significant figures. So the significant figures indicates the precision of measurement, which depends on the least count of your measuring instrument. So as I said, I can measure 5.1 or 5.2 in my previous explanation, but I cannot measure 5.13 or I cannot measure 5.15. or I cannot measure 5.56, something like this. Second decimal accuracy I am not getting, right? So that is because of the least count of the scale which I had chosen is 0.1 centimeter. I am talking about the normal scale which you use in daily. So ಅದರ least count ಎಷ್ಟು ಇರುತ್ತೆ 0.1 centimeter ಇರುತ್ತೆ. Okay, so this significant figure indicates the precision, at what precision I am doing the measurement. Okay, and also we have to understand that a choice of change of different units, okay, should not change the number of significant digits in a measurement. So this is very important. Okay, if I change the number of if I change the units, for example I write in meters and then I go for centimeters maybe or kilometers maybe, it should not change the number of significant digits. Okay, so that is the idea which we have to keep in our mind. So that should be the thumb rule to set the rules of finding out the significant figures. Okay, so here some rules are given. So let us quickly have a look one by one. The first one is all the non-zero digits are significant. Okay, so ಏನಿದೆ all the non-zero digits are significant. So for example, previously I think we took one as well, right? Yeah, that is 23.54. Ali 2, 3, 5, 4 all are non-zero digits and hence all are significant. So I can say one more example. I'll say, so let me take like 32.456. So ಏನಾಗುತ್ತೆ ಇದರಲ್ಲಿ, how many number of significant digits are there? So there are 5 significant digits. Okay, so I'll just say 5SF. Hope you are following. Yeah. So next, if I have one more number like without decimal, let us say something like 357. Okay, how many number of significant figures are there? Here 3 significant figures. Yes, very good. 5 significant figures in this first example. Very good. Okay, so moving to the second rule, all the zeros between two non-zero digits are significant no matter where the decimal point is. Okay, so decimal point idru a number alli illade idrunu the zeros between two non-zero digits are significant. Yes, there are 3 significant figures in the second example. Very good. So idukku ಒಂದು example ತಗೊಳ್ಳೋಣ. Zeros between two non-zero digits. Let me say 205. So what are the number of significant figures here? Yeah, and I'll say one more, 21.5203. So please tell me what is the number of significant figure in this 205? Yeah, here it is 3 significant figures, and here it is in the second example 21.5203. There are 6 significant figures. Yes, very good. Very good. Okay, so there are 3 and 6 significant figures in these two examples respectively. Okay, so if there is a zero between any two non-zero digits, they are going to be significant. Okay, so next is, so the next rule. Okay, so all these rules are set by keeping in our mind that if I go from one system of unit to other system of unit, it is not supposed to change the number of significant figures. Okay, next is if the number is less than 1. So this is very important. This is applicable if the number is less than 1, something like 0 point something ಆ ತರ ಇರುತ್ತಲ್ಲ ಆ ನಂಬರ್ಗೆ, the zeros on the right of decimal point but to the left of the first non-zero digit are not significant. Okay, so on the example ತಗೊಂಡು explain ಮಾಡೋಣ. So let me say that is 0.00125 ಅಂತ ಇದೆ. ಸೊ ಇಲ್ಲಿ 2 ಪಾಯಿಂಟ್ ಕ್ಲಬ್ ಮಾಡಿ ಕೊಟ್ಟಿದ್ದೀನಿ ನಾನು. ಸೊ ಏನಿದೆ, ಸೊ One is the zeros on the right of decimal. So decimal point illide to its right means these two zeros are not significant. Okay, up to first non-zero digit. So the zeros up to first non-zero digit. ಇಲ್ಲಿ first non-zero digit ಯಾವುದಿದೆ 1 ಇದೆ. So ಅದಕ್ಕೂ ಮೊದಲು ಇರುವ 0 after the decimal point. ಇಲ್ಲಿ decimal point ಆದ ನಂತರ ಇರುವ 0 up to the first non-zero digit for a number which is less than 1. Okay, so that is very important. For a number which is less than 1, okay, they are not going to be significant. And also ಇನ್ನೊಂದು point ಏನಿದೆ, and also the digit 0 conventionally put on the left of the decimal for a number less than 1 is never significant. Andre E0. This is also not significant. Okay, so ಇಲ್ಲಿ total, what is the number of significant figures in 0.00125? Can someone tell me what is the number of significant figure in 0.00125? Anybody? So it's going to be 3. Only 1, 2 and 5 are significant. So I can say 3 significant figures. Okay, it's going to be 3 significant figures. Okay, is that clear? Hope it is clear. Yeah. Okay, so moving to the next rule, that is the terminal or trailing zeros in a number without a decimal point are not significant. So again, this is one very important point. If there is no decimal point in the given number, then the trailing zeros andre end alli baruva zeros are not significant. For example, if I say 240, okay, so illi enagutte, this 0 is not significant. Okay, so our 0 is not significant. Only these two are significant. So I can say 2 significant figures. Okay, there will be only 2 significant figures. Is that clear? Hope you're following. Yeah. So this is one another rule in terms of significant figure. Okay. So next is, yeah, if any doubts, please rise in chat box. I'm looking for some doubts if you have. I think there are no doubts mentioned here. Yeah. Okay, moving ahead to the next one. The trailing zero in a number with decimal point are significant. So if at all there is a decimal point, then all the ending zeros are significant. For example, I say like 1.20. So illi enagutte, all these 3 are significant. Okay, similarly, if we have some number like 25.0, so again 3 significant figure. So please remember, decimal point idre the ending zeros are significant. Okay, is that clear? Okay, I think we can just go ahead. The next one is the multiplying or dividing factors which are neither rounded numbers nor numbers representing measured values are exact and have infinite number of significant digits. Yeah, I think now I got some response for some question as 2 significant figures. I think yes, Chinni, please let me know for which question your answer is 2, because in this slide, whatever the example I had given, both are going to have 3 significant figures. So please count the 0, the ending 0, if there is a decimal point. If it was like 250, so ille enagutte only 2 significant figure. Okay, because 25.0 ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನಿದೆ, ಅಲ್ಲಿ ಡೆಸಿಮಲ್ ಇದೆ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ಡೆಸಿಮಲ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಯು ಹ್ಯಾವ್ ಟು ಕೌಂಟ್ ದಿ ಟ್ರೈಲಿಂಗ್ zeros. ಓಕೆ, ಬಟ್ 250 ಅಂತಿದ್ರೆ 2 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್, 25.0 ಇದ್ರೆ ಅದು 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್. ಓಕೆ, ಹೋಪ್ ಯು ಗಾಟ್ ದಟ್ ಪಾಯಿಂಟ್ ಆಸ್ ವೆಲ್. ಓಕೆ, ಸೊ ಇಲ್ಲೇನಿದೆ, if there are some numbers, I'll give you one formula like diameter or radius is diameter by 2. So that's, we usually use this formula. Hope you all are familiar, right? Radius is diameter by 2 or circumference is equals to 2 pi r anta bariತೀವಿ. ಇಲ್ಲಿ ಏನಾಗಿದೆ, this 2, it's a number, right? It's not a rounded off number. It's a proper, it's not even a measured value. It is not even a rounded off value. It's a number. And whenever we are having this exact numbers, they are going to have infinite number of significant digits. Okay, so they are going to have infinite number of significant digits. Is that clear? Any doubts? So formula alli baruva numbers iruttalla which are not rounded off, they are always going to be infinite number of significant digits. Okay, even if you have the value of pi. So depending on the situation, you can take 3.14 to 3.14 like that. So it is going to have infinite number of significant digits. Okay, so here are some example. Quickly you can try answering these. Some of you are there, try answering. Yeah, yes Chinny, you were right for that answer 3. So we are having some examples like, state the number of significant figures in the following data. So one is 0.007 is there. Okay, so here what are the number of significant figures? Yeah, can someone tell? So this is a number less than 1. So these zeros are not significant. So only one significant figure. Then we have a number like this, 2.64 into 10 power 24. So what is the number of significant figure here? So the powers of 10 are not significant. We have to consider only this, that is 2.64, which means it is going to have 3 significant figure. Okay, please try answering. Next one is 0.2370. These 4 significant figures, because 2370 all are significant. Decimal is there, decimal point is there, so 0, the ending 0 is significant. So again here, so 1 2 3 4 significant figures, and then 6.032. so this 0 is between 2 non-zero numbers, hence all are significant there. So we'll be having 4 significant figures. Then we have one more number, 0.0006032. Yeah, so here again these zeros which are just after the decimal and before the first non-zero digit are not significant. So ಇಲ್ಲಿ significant ಯಾವುದು, only the 6032 are significant, and hence we can say 4 significant figures. A is 1. Very good, very good. Happy that you are following. Okay, hope it is clear till here. We can go ahead to the next concept. Yeah, that is, there is one situation occurs. Okay, depending, it is with respect to the trailing zero. As I already told you, decimal point illa andre trailing zero na consider ಮಾಡಬಾರದು ಅಂತ. Okay, so ಅಲ್ಲಿ sometimes ambiguity ಬರುತ್ತೆ or problems ಬರುತ್ತೆ or confusion ಬರುತ್ತೆ. So ಒಂದು example ತಗೊಂತೀನಿ. Let us say we have measured length. Okay, so ಯಾವುದೋ ಒಂದು length measure ಮಾಡಿದೀವಿ. So let us say its length measured as 4.160 in meters, let us say. Okay, so ಯಾವುದೋ ಒಂದು 4.160 meter ಇದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡೋಣ. Okay, so illi what is the number of significant figure? So decimal point ide, so illi eshtagatte 4 significant figure ಆಗುತ್ತೆ. Hope everyone agrees with me. Yeah. Yes, for other question also you have answered. I hope your answer is syncing with what I had written. Yes, correct. It's very good. So here, yeah, so ಇದನ್ನ ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ? So that is like, so 416.0 centimeters ಆಗುತ್ತೆ. Do you agree? And what is the number of significant figure? Still it is 4 only. Hope you are following. Yes. Yeah. So we have measured the length as 4.160 meters and 4 significant figures are there, no doubt. Now I have, converted into centimeter. So still I am getting 4 significant figure. Now I'll convert it into millimeter. Millimeter means 10 power minus 3 meter. Correct? So again, this can be written as 4160 millimeters. But illiga, what is the number of significant figures? So here 416 are significant. So we get something like 3 significant figure here. But this is wrong. Because if we go from one unit to other unit, okay, one system of unit to other system of unit, it is not supposed to change the significant figures or significant digit. Okay, so illenagide, there is no decimal point here, right? No decimal. So trailing 0 ಏನಾಗುತ್ತೆ? Not significant ಆಗುತ್ತೆ according to the rules if we go. But ಅದೇ measurement ಅಲ್ಲಿ, when I have measured and expressed in meters, I am getting 4 significant figure. But here I am getting 3 significant figure. So what to do? Yeah, some correction or some, standard method to be followed then, correct? Yes or no? Some methods needs to be followed. So adana enantivi scientific notation. So what we should do? We should follow something called as scientific notation in order to avoid these kind of confusions. When there is a trailing 0 in the measured value, when we go from one system of units to the other system, okay, we may end up with, some confusions. In order to avoid that, what we had to do, yeah, we had to go for scientific notation. Okay, so in scientific notation heng baritvi, any measured value can be written as a into 10 power b, where a is, the numerical value, okay, and this 10 power b is something like, the 10 power b whole is called as order, and illi b annodi idiyalla, that is called magnitude, order of magnitude, sorry. Okay, so illi enagbeku, this a into 10 power b idella, so this a will be always a number between 1 to 10. So ನಾವು ಆ ತರನೇ ಬರೀಬೇಕು. ಅಂದ್ರೆ ಏನಾದರೂ ಡೆಸಿಮಲ್ ಇದ್ರೆ we had to put that decimal just after the first digit, so that we get a number between 1 to 10. Okay, a is a number between 1 to 10 and b is any positive or negative exponent depending on the situation. Okay, ಈಗ previous example ತಗೊಂಡ್ರೆ ಏನಿದೆ ಅಲ್ಲಿ 4.160 ಅಂತಿದೆ. So this is fully measured value. ಇದನ್ನ ನಾನು ಏನು ಮಾಡೋದೇ ಬೇಡ, 4.160 in meter anta measure ಮಾಡಿದೀನಿ. So this comes only when with respect to measured values. Okay, ಇದನ್ನ ಈಗ problem ಎಲ್ಲಿ ಬಂತು ನನಗೆ, when I try to write it in millimeters. So ಈಗ ಏನು ಮಾಡಬಹುದು, this can be written as 4.160 into 10 power minus 2, sorry, plus 2 centimeter. Can I write like that? Yeah. So ಏನು ಬರಿಬಹುದು, this is equivalent in saying 4.160 into 10 power 2 centimeter. This is also equivalent in saying 4.160 into 10 power 3 millimeter, because milli means 10 power minus 3. ಸೊ 10 ಪವರ್ ಪ್ಲಸ್ 3 ಮೈನಸ್ 3 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಸೇಮ್ ನಂಬರ್ ಬರುತ್ತೆ. ಅದೇ ತರ 10 ಪವರ್ ಪ್ಲಸ್ 2 ಸೆಂಟಿಮೀಟರ್ ಅಂತಿದೆ, ಸೆಂಟಿ ಮೀನ್ಸ್ 10 ಪವರ್ ಮೈನಸ್ 2. ಸೊ ಅಗೇನ್ ಐ ಗೆಟ್ ದಿ ಸೇಮ್ ವ್ಯಾಲ್ಯೂ, ಕರೆಕ್ಟ್. ಬಟ್ ಈಗ ಇಲ್ಲಿ ಏನಾದ್ರೂ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್ ಚೇಂಜ್ ಆಗಿದೆಯಾ? ಬಿಕಾಸ್ ಪವರ್ಸ್ ಆಫ್ 10 ಆರ್ ನೆವರ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್, ಕರೆಕ್ಟ್. ಪವರ್ಸ್ ಆಫ್ 10 ಯಾವಾಗ್ಲೂ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಆಗಿರೋದೇ ಇಲ್ಲ. ಸೊ ಇಲ್ಲೂ 4 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್, here also 4 significant figure, here also 4 significant figure. Okay, so in all the 4 cases we are getting 4 significant figure. So now ಏನ್ magnitude ನಾವು measure ಮಾಡಿರ್ತೀವಲ್ಲ, that is A, so that should be completely written, and the zeros in that magnitude, all the zeros in that magnitude are significant. Okay, is that clear till here? So this is how we follow a scientific notation. Quickly respond, please. Yeah. Okay, so going next, order of magnitude. As just I have told you, physical quantity expressed in terms of powers of 10, nearest to the magnitude of that quantity. So ಇಲ್ಲಿ order of magnitude ಅಂದ್ರೆ scientific notation ಹೇಗೆ ಬರೀತೀವಿ, a into 10 power b ಅಂತ ಬರೀತೀವಿ. ಯಾವ್ದಾದ್ರೂ ನಂಬರ್ ಕೊಟ್ಟು, in MCQs it is possible, they will tell you to get the order of magnitude. ಇಲ್ಲಿ ಒಂದು small method ನ follow ಮಾಡಬೇಕು. So we had to approximate the given number, okay, or round off ಮಾಡಬೇಕು. For if this a ಇಲ್ಲಿ ಇದೆಯಲ್ಲ, if this a is less than or equal to 5 ಇದ್ರೆ, so a ನ 1 ಗೆ approximate ಮಾಡಬೇಕು, and b will be your order of magnitude ಆಗುತ್ತೆ. ಅದೇ ತರ if this a is greater than 5, less than or equal to 10 ಇದ್ರೆ ಏನಾಗುತ್ತೆ, so we had to approximate a to 10, okay, round off to 10, and ಆಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ b ಅಂತ ಏನಿತ್ತಲ್ಲ ಅದು b plus 1 ಆಗುತ್ತೆ. Okay, so that will be the order of magnitude. Okay, so that the exponent or power of b is called order of magnitude. One example ಕೊಡ್ತೀನಿ, ಆಗ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. So what I was trying to say is, if I have a number like 2.3 into 10 power 5, so order of magnitude ಇದನ್ನ ಹೆಂಗ್ ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ, a into 10 power b ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ. ಸೊ ಇಲ್ಲಿ a ಅಂದ್ರೆ ಏನಿದೆ, 2.3 ಇದೆ, which is clearly less than 5. ಸೊ ಆಗ ಏನ್ ಮಾಡಬೇಕು, a ನ you have to approximate it to 1. ಸೊ ಅವಾಗ 1 ಗೆ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಬಂದಿರೋದು ಏನ್ ಬಂತು ನಮ್ಗೆ ಅವಾಗ, ಸೊ 1 into 10 power 5 ಆಗುತ್ತೆ. ಸೊ 5 will be order of magnitude. Okay, so ಏನಿಲ್ಲ, if the magnitude is less than 5, ಇಲ್ಲಿ ಏನ್ b ಇದೆ ಅಲ್ಲ, that itself will be your order of magnitude. Okay, ಅದೇ if magnitude, whatever this number is there, no, if it is greater than 5, so this is one example. Second example, I'll say I have something like 8.72 into 10 power 3 ಅಂತಿದೆ ಅನ್ಕೊಳ್ಳಿ. ಓಕೆ, ಸೊ ಅಗೇನ್ ಕಂಪೇರ್ ಇಟ್ ಆಸ್ a into 10 power b. ಸೊ a ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಿದೆ, 8.7 ಇದೆ. ಸೊ 8.7 is greater than 5. ಸೊ ಈ ಕೇಸಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, ನಾವು ವಿ ಹ್ಯಾಡ್ ಟು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ a to 10. ಸೊ ಆಗ ನಂಬರ್ ಏನಾಗತ್ತೆ ನಮ್ಗೆ, 10 into 10 power 3 ಆಗತ್ತೆ. ಈ 8.72 ನ we have to approximate to 10. ಸೊ ಇಲ್ಲೇನಿತ್ತು, 2.3 ಇತ್ತು, 2.3 ನ 1 ಗೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಮಾಡ್ತೀವಿ, ಇಲ್ಲಿ 8.7 ನ 10 ಗೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಮಾಡ್ತೀವಿ, or this is something like 10 power 4. Okay, yeah, hope it is clear. So ಈಗ ಇಲ್ಲಿ order of magnitude ಏನಾಗುತ್ತೆ, 4. This one, 4 is the order of magnitude. Okay, in this case. So less than 5 idre b itself is the order of magnitude. If greater than 5, a is greater than 5 ಆದ್ರೆ b plus 1 ಆಗುತ್ತೆ. ಆ ತರನು ನೆನಪಿಟ್ಕೊಳ್ಬಹುದು. Okay, yeah, is that clear? Yes, hope it is clear to everyone. So moving ahead, so this is about scientific notation and its importance, and to get the order of magnitude. So order of magnitude now MCQ ಅಲ್ಲಿ ಕೇಳಬಹುದು. Okay, just by giving a number, how to get the order of magnitude. And there are two more simple concepts to learn with respect to significant figure, that is in the case of arithmetic operations. So because if I'm getting a result, it is not that with one step I got it, right? I had to do several calculation, I had to take formula, I had to substitute, I had to do addition, subtraction, multiplication, division, everything, right? So ಅಲ್ಲಿ significant figures ಗೆ ಒಂದು ರೂಲ್ ಇದೆ. again a standard rule. ಸೊ ಎರಡೇ ರೂಲ್ ಇರೋದು, ಇಟ್ ಇಸ್ ವೆರಿ ಈಸಿ ಟು ರಿಮೆಂಬರ್. ಸೊ ಏನ್ ಮಾಡಬೇಕು, ಅಡಿಷನ್ ಮತ್ತೆ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡಬೇಕಾದ್ರೆ ಫೈನಲ್ ರಿಸಲ್ಟ್ ಅಲ್ಲಿ ವಿ ಶುಡ್ ರಿಟೈನ್ ಆಸ್ ಮೆನಿ ಡೆಸಿಮಲ್ ಪ್ಲೇಸಸ್ ಆರ್ ದೇರ್ ಇನ್ ದಿ ನಂಬರ್ ವಿತ್ ಲೀಸ್ಟ್ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್. ಸೊ ಕೊಟ್ಟಿರುವ ಗಿವನ್ ಡೇಟಾ ನೋಡ್ಕೋಬೇಕು. ಸೊ ಅದರಲ್ಲಿ ಯಾವ ನಂಬರ್ ಅಲ್ಲಿ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಕಡಿಮೆ, ಲೀಸ್ಟ್ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಕಡಿಮೆ ಇದೆಯೋ, ಸೊ ಫೈನಲ್ ಆನ್ಸರ್ ಶುಡ್ ಬಿ ರೌಂಡೆಡ್ ಆಫ್ ಟು that least decimal place. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ ಕ್ವಿಕ್ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ಲೆಟ್ ಮಿ ಸೇ 22.34 and ಇದಕ್ಕೆ ಲೆಟ್ ಅಸ್ ಸೇ ವಿಲ್ ಆಡ್ ಸಮ್ ಸ್ಮಾಲ್ ನಂಬರ್, ಲೆಟ್ ಅಸ್ ಸೇ ಸಮ್ 4.1. ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಅಡಿಷನ್. ಓಕೆ, ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ, ವಾಟ್ ಇಸ್ ದಿ ನಂಬರ್, ಇಲ್ಲಿ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್ ಅಲ್ಲ, ಇಲ್ಲೇನಾಗಿದೆ 2 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಇದೆ. ಓಕೆ, 2 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಇದೆ, ಇಲ್ಲಿ 1 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಇದೆ. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಲೀಸ್ಟ್, ರೈಟ್? ಸೊ 4.1 ಅಲ್ಲಿ ಏನಿದೆ, ಲೀಸ್ಟ್ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್. ಓಕೆ, ಸೊ ಈಗ ಆಡ್ ಮಾಡೋಣ. ಸೊ ಏನ್ ಬರುತ್ತೆ ನಮಗೆ, ಸೊ 4, 4, 6 and 2, ಕರೆಕ್ಟ್? ಸೊ 26.44 ಬಂತು. ಇಲ್ಲೇನಾಗಿದೆ, 2 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಇದೆ. ಓಕೆ, ಸೊ ವಾಟ್ ವಿ ಶುಡ್ ಡೂ, ವಿ ಹ್ಯಾವ್ ಟು ರೌಂಡ್ ಇಟ್ ಆಫ್ ಟು 1 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್. ಸೊ ಫೈನಲ್ ಆನ್ಸರ್ ಅಲ್ಲಿ 1 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಇರಬೇಕು ನಮಗೆ, ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಆಸ್ ಗಿವನ್ ಇನ್ ದಿ ಗಿವನ್ ಡೇಟಾ. ಸೊ 1 ಡೆಸಿಮಲ್ ಪ್ಲೇಸಿಗೆ ರೌಂಡ್ ಆಫ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ 1 ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, 26.4 ಆಗುತ್ತೆ ಫೈನಲ್ ಆನ್ಸರ್. ದಿಸ್ ವಿಲ್ ಬಿ ಯುವರ್ ಫೈನಲ್ ಆನ್ಸರ್. ಸೊ ವಿ ವಿಲ್ ಬಿ ಡ್ರಾಪಿಂಗ್ ದ ನೆಕ್ಸ್ಟ್ ಡಿಜಿಟ್. ಓಕೆ, ಸೊ ಇದನ್ನ ಡ್ರಾಪ್ ಮಾಡ್ತೇವೆ. ಸೊ 26.4 ವಿಲ್ ಬಿ ಯುವರ್ ಫೈನಲ್ ಆನ್ಸರ್. ಓಕೆ, ಯಾ, ನೆಕ್ಸ್ಟ್ shall we move ahead? Any doubts, please rise in the chat box. So similarly we have a rule in the case of multiplication and division. So multiplication and division ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ಸಿಮಿಲರ್ ಬಟ್ ಇಲ್ಲಿ ಲೀಸ್ಟ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ತಗೋತೀವಿ. ಅಡಿಷನ್ ಅಂಡ್ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ಫೈನಲ್ ಆನ್ಸರ್ ಶುಡ್ ಹ್ಯಾವ್ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಡೆಸಿಮಲ್ ಪ್ಲೇಸ್ ಆಸ್ ಗಿವನ್ ಇನ್ ದಿ ಗಿವನ್ ಡೇಟಾ, ಬಟ್ ಇಲ್ಲಿ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್. ಓಕೆ, ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡೋಣ, ಅಗೇನ್ ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋಣ. ಸೊ ಲೆಟ್ ಮಿ ಸೇ 22.1 into 1.5 ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡಬೇಕು. ಓಕೆ, 22.1 into 1.5 ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡಬೇಕು. ಸೊ ಇಲ್ಲಿ ಫಸ್ಟ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್ ಬರೆಯೋಣ. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ, 1.5 ಅಲ್ಲಿ 2 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ಇದೆ, ಇಲ್ಲಿ 22.1 ಅಲ್ಲಿ 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ಇದೆ. ಸೊ ಫೈನಲ್ ಆನ್ಸರ್ ಅಲ್ಲಿ ಏನಾಗಬೇಕು, ಫೈನಲ್ ಆನ್ಸರ್ ಮಸ್ಟ್ ಬಿ ಇನ್ 2 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್, ಬಿಕಾಸ್ ಲೀಸ್ಟ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ಗಿವನ್ ಡೇಟಾದಲ್ಲಿ ಯಾವುದು, 1.5 ಅಲ್ಲಿ 2 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ಇದೆ. ಸೊ ಫೈನಲ್ ಆನ್ಸರ್ must be in 2 significant figures. Okay, with respect to this. Yeah, so we'll just multiply here. So that is like 15. So I think this is correct. 33. Yeah, I think somebody is answering for the previous question. Yeah, 33.15 agata. So this is like 33.15. Just check once. Yeah, so this is correct. And here what we should do, illige ಎಷ್ಟು significant figure ಆಯ್ತು. So this has 4 significant figure. Correct. So we have to round it off to 2 significant figure. So that means only 33 will be your answer, because we are dropping at this 1, correct? We are dropping at 1. 1 is less than 5. Okay, so we will just keep the number as it is. If we had a number like 33.6, we had to round it off as 34. So that is also there in the next part. Hope it is clear till here with respect to the addition, subtraction, least decimal place. With respect to multiplication and division, you have to keep the least significant figures in the given data. Yes, any doubts? Please raise your doubt in the chat box. Yeah. Moving ahead. So that is rounding off of the uncertain digit. Already ಹೇಳಿದ್ದೀನಿ. So ಏನು ಮಾಡಬೇಕು? Whenever we are given with a number, okay, so we had to round it off with respect to the required significant figure. So 3 ಈಗ 4 ಡಿಜಿಟ್ ಇದೆ, ನನಗೆ 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ಬೇಕು ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಡಿಜಿಟ್ ನ ರೌಂಡ್ ಆಫ್ ಮಾಡ್ತೀವಿ. ಸೊ ಕನ್ವೆನ್ಷನಲ್ ಮೆಥಡ್ ಏನು? ಯಾ, if the preceding digit is raised by 1, if the digit to be dropped is more than 5, 5 ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ preceding digit ನ 1 ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀವಿ, and it is kept as it is if it is less than 5. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ಬಿಡೋಣ, ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 22.34 ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಓಕೆ, ಸೊ ಇದನ್ನ ರೌಂಡ್ ಆಫ್ ಟು 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್. ಓಕೆ, round off to 3 significant figure. So ಏನಾಗುತ್ತೆ, here we had to drop this 4 then, correct? We will be dropping this. So this 4 is less than 5. So ಏನಾಗುತ್ತೆ ಈಗ round off ಮಾಡಿದ್ರೆ, so this will be 22.3 itself, because less than 5 ಇದೆ. ಅದೇ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋಣ, that is 22.37 ಇದೆ. Same, round off to 3 significant figure. Okay, we are rounding it off to 3 significant figure. So ಇಲ್ಲಿ ಏನಾಗಿದೆ, this is 7 more than 5. So ಈಗ ಏನು ಮಾಡಬೇಕು, we had to increase the preceding digit by 1, ಅಂದ್ರೆ 22.4 ಆಗುತ್ತೆ. Yeah, it's a simple rule which we might be doing from our school days, right? So 22.4 ಆಗುತ್ತೆ. ಗ್ರೇಟರ್ ದ್ಯಾನ್ 5 ಇದ್ರೆ ಪ್ರಿಸೀಡಿಂಗ್ ಡಿಜಿಟ್ ನ 1 ಇನ್ಕ್ರೀಸ್ ಮಾಡಿ, ಲೆಸ್ ದ್ಯಾನ್ 5 ಇದ್ರೆ just keep as it is. Okay, so this is one, and there is one more thing. If the dropping digit itself is 5, so again ಇಲ್ಲಿ ಎರಡು ಕೇಸ್ ಬರುತ್ತೆ. So dropping digit 5 ಇದ್ರೆ ನಾವು previous digit ನ ನೋಡಬೇಕು, whether it is even or odd. So even ಇದ್ರೆ we will just keep that number as it is. If it is odd, we had to increase the preceding digit by 1. Okay, so one example ತಗೊಳ್ಳೋಣ again. So let me say 22.35 ಇದೆ. So ಇಲ್ಲಿ dropping digit 5. Okay, so preceding digit ಏನಿದೆ, we have to drop this. Let us imagine that we are rounding it off to 3 significant figures. Okay, so we have to drop 5. Okay, this 3 is odd. So if it is odd, what we should do? Odd plus 1. So which is going to give us 22.4. Okay, so ಅದೇ ತರ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ 22.47 or okay 45 we will say. Okay, 22.45 ತಗೊಳ್ಳೋಣ. Again we had to drop 5. So this is applicable only if the dropping digit is 5. Okay, so ಈಗ previous ಏನಿದೆ, even ಇದೆ. So even ಇದ್ರೆ keep as it is. Keep as it is. So ಅಂದ್ರೆ 22.4 ಇರುತ್ತೆ. Okay, 22.4 ಇರುತ್ತೆ, 5 ಆಗಲ್ಲ. Okay, so this is how we round off the numbers. Is that clear? Yes, thank you for your response. 22.4 in both the cases. Yeah, I think you also got your doubt solved here itself if the dropping digit is 5, correct? That was your doubt, Chinni? Yeah, hope that is clear. I think we can go ahead. I think that was your doubt. Okay. So now coming to the other important concept, very, very important. You can expect 1 3 mark and 1 2 mark question, or maybe like, 1 3 mark question and some MCQs, or fill in the blank from the concept of dimensions. Yes, thanks for your response. So we'll just move ahead to the next concept, that is dimensions of physical quantities. So again ಇಲ್ಲಿ ಎರಡು ಸಬ್ ಟಾಪಿಕ್ ಮಾಡ್ಕೋಬಹುದು dimension ಅಲ್ಲಿ. So ಒಂದು learning how to get the dimensions of physical quantities, the other one is application part. Okay, so how much is possible we learn till the application. If some application of the dimension is left, so that will be discussed in next class, that is tomorrow's class, where as a question and answer. Okay, so we can discuss like that as well. Okay, so dimension of a physical quantity. So here the dimensions of a physical quantity are the powers to which the base quantities are raised to represent the given quantity. So we will be having some physical quantity. Let us hope it's a derived quantity. Okay, so now we know that this derived quantity can be expressed in terms of the fundamental quantity. All the derived quantities can be expressed in terms of fundamental quantities, right? So to which power we rise? Okay, directly I cannot say velocity is nothing but length. That is wrong, right? Or saying force as mass or something like length or time, that is 100% wrong. So if I want to express a derived quantity in terms of the base quantity or fundamental quantity, I had to rise the fundamental quantity to some powers. Okay, so that method is called as dimensions of physical quantity. So dimension of physical quantity na hege represent ಮಾಡ್ತೀವಿ, that is with the help of square bracket. Okay, so square bracket ಒಳಗೆ ಬರ್ದೆ ಅಂದ್ರೆ it is understood I am talking about the dimension. For example, I say like square bracket of L. This is nothing but the dimension of length. Okay, then mass, how do we represent? M. Then time, capital T. Okay, in mechanics, like whatever you study in mechanics, like kinetics, kinematics, all those things, laws of motion, most of your first NCERT part 1, all the quantities can be expressed in terms of MLT. Though there are 7 fundamental quantities, most of these kinematic quantities can be expressed in terms of 3 fundamental quantities, that is MLT. And also you can have other physical quantities like current. Current andre hege bariತೀವಿ, its unit is ampere, so we write it as square bracket A. This is the dimension of current. Okay, then mole, the dimension of mole, amount of substance. Okay, is that clear? Similarly, you can write for temperature, capital K. So I hope it is visible if I write here. Okay, and luminous intensity, that is CD, you can write candela. Okay, so like that. And I think temperature is done, current is done. Yeah, so this is how you represent the dimensions of basic or fundamental physical quantity. But our job is to get the dimensions of the derived quantity. Okay, so in one the definition baratte, that is dimensional equation andre enu, or dimensional formula andre enu. Okay, so it is nothing but equating the physical quantity with their dimensional formula. So that is called as dimensional equation. Enilla equation andre ಒಂದು equality symbol idde irutte. So we are equating the physical quantity to its dimensional formula. That is what we call it as dimensional equation. So it is nothing like, one simple example we'll take. So I will say velocity. Okay, so the quantity which I am choosing is velocity. So velocity a dimension. So notation V anta use ಮಾಡ್ತೀನಿ. So dimension of velocity will be LT minus 1. Because velocity andre heng baritira? Displacement, correct? Divided by the time. Yes or no? Hope you're following. Yeah, any doubts? Any doubts? Please respond in the chat box. Yes, your definition for dimension and the dimensional formula is also correct. Very good. Happy that you're still following. Okay. So, coming to the point here, that is dimensional equation. So, one the particular physical quantity, other dimension jote equate ಮಾಡಿ ಬರಿತೀವಲ್ಲ, that is called as dimensional equation. Okay, so let us try to learn some dimensions of some simple physical quantity like velocity. Next is force, I say. So how do you define force? So either you should know the unit of that quantity or you should know the formula. Whichever is easy, we can follow that. So force andre nange gottu, mass into acceleration. Okay, before that we'll try to write the dimension of acceleration as well. Okay, so let me say the other quantity I'm choosing is acceleration, which is represented by A. So acceleration andre velocity by time, alva? So we know that acceleration is velocity by time. So velocity dimension enide LT minus 1 divided by T anta baribodu, or this will give us LT minus 2. Okay, so you should remember all those things. No one will tell you, at each and every step, like, they don't follow. Acceleration means LT minus 1 by T. Every time you don't have, you are not supposed to do like that. You have to remember. Okay, LT minus 2. Velocity, LT minus 1. Displacement, just the length. Okay, so now the dimension of force. How do you write? Mass into acceleration, right? M stands for the dimension of mass and acceleration means LT minus 2. Correct? Hope you're following the dimension. Yeah. So the next one we'll take is momentum. There's one more quantity, that is momentum. Okay, so usually represented by the symbol P. So the dimension of momentum P, so it is given by mass into velocity. Okay, so momentum andre mass into velocity. So don't worry with respect to the dimensions of the new physical quantities. By the end of your first PUC and second PUC, you will be learning many number of new physical quantities, and you will definitely be familiar with all the formulas of these physical quantities. Aga dimension bariyod easy age agutte. So first chapter agirodrinda maybe like another 2-3 months ಅಲ್ಲಿ dimensions of some physical quantity ನಾನು ನಿಮಗೆ ಕೇಳಿದ್ರೆ ಕಷ್ಟ ಆಗ್ಬೋದು, but with time you will be used to it. Okay, so then you will appreciate, like when you come to the end of your midterm of your first year or first PUC, you will tell, okay, the easiest chapter in physics is units and dimension. But ಇವಾಗ ನಿಮ್ಗೆ ಇದೇ ಕಷ್ಟ ಆಗ್ತಿರುತ್ತೆ, because all these are new physical quantities. ನಿಮಗೆ ಅದರ formulas ಗೊತ್ತಿರಲ್ಲ. Okay, so suddenly some in some test they will ask you coefficient of viscosity, what is the dimension of latent heat, hangandre ಏನು ಅಂತಾನೆ ನಿಮಗೆ ಗೊತ್ತಿರಲ್ಲ ಈ ಮೂಮೆಂಟ್ ಅಲ್ಲಿ. But with time, by the end of maybe till December, you learn all those physical quantities and ಅದರ dimension ನ ಆರಾಮಾಗಿ ಬರೀತೀರಾ ನೀವು. Okay, so momentum m into v ಅಂತ ಹೇಳಿದೆ. So that is like m L T minus 1. Yes, if you are following, please respond. Hope there are no doubts. So the next one, I'll take energy. This is very important. Frequently and widely asked, the dimension of energy. Okay, so energy andre, okay, first we'll write down work done, then I'll go to energy. That will make your understanding little in a better way. So we'll take work done first. Just a second, some issue. problem with this. 1 second. Okay, something is wrong with this writing space. Let me just see. So we have work done. Hope it is fine now. Yeah, almost fine, but still the words are dancing somewhere. Okay, so work done. Okay, so work done usually ಹೇಗೆ represent ಮಾಡ್ತೀರಾ? W ಅಂತ ಬರೀತೀರಾ. W which is given by force into displacement ಅಂತ ಬರೀತೀರಾ. Correct? So ಈಗ dimension of work done will be dimension of force into the dimension of displacement ಅಂತ ಹೇಳ್ಬೋದು. Correct? So dimension of work done is, so dimension of force ಏನು? MLT minus 2 into the dimension of displacement is L, or this will give you the dimension of work done as ML square T minus 2 agate, because here one L, here one L, so L into L will give us L square, or L raised to power 1 and L raised to power 1, which will give us L square. Okay, ML square T minus 2. Okay, so this is how you get the dimension of work done. Yeah, most of the problems will be discussed in this class. If anything goes beyond 8 p.m, then that will be discussed along with your question discussion in the next session. Okay, hope it is clear. ML square T minus 2. Yes, very good, thanks for your answer. And now we know that the unit of work done is joules, and energy is nothing but the capacity to do work. We know that definition from our high school, right? Energy andrenu, it is the capacity to do work. Andre adruddu unit joule, then they are going to have same dimension. Okay, many physical quantities can have the same dimension. Okay, unit same ide andre adra dimension same irutte. It need not be always unit same irodrud matra dimension same irutte anta alla. So many physical quantities are going to have the same dimension. So ಈಗ ಏನು ಹೇಳ್ಬೋದು, energy dimension ಅನ್ನು we can simply say like the dimension of work done. Okay, so which is nothing but ML square T minus 2. Okay, hope it is clear. Any doubts, please let me know. Any doubts, please let me know. Yeah, so next is after energy, work done, force we did. These are all quantities which we'll be using now and then. Velocity, momentum, acceleration, and then we can say there's one more quantity, that is pressure. Okay, two we'll take. One is pressure. Pressure is force by area. Okay, so dimension of pressure is dimension of force by area, or this will give us dimension of force is MLT minus 2 divided by the dimension of area is L square. Area is like length into breadth kind of a thing, right? It has two dimension in length. So this is going to give you the dimension of pressure as M L minus 1 T minus 2. Okay, hope you can see here. M L minus 1 T minus 2 is going to be the dimension of pressure. Yes, which one you are asking? Somebody is asking question like yake. What's your doubt? If there is a genuine doubt, please ask. And you have mentioned like force is mass into acceleration. That is absolutely correct. And we are also done with pressure. And one more, what we are going to do is power. Power is nothing but rate of doing work. Andre ಏನು ಹೇಳ್ತೀವಿ, ವರ್ಕ್ ಡನ್ ಬೈ ಟೈಮ್ ಅಂತಾನೂ ಹೇಳ್ಬೋದು, ಎನರ್ಜಿ ಬೈ ಟೈಮ್ ಅಂತಾನೂ ಹೇಳ್ಬೋದು. ಓಕೆ, ಯಾ. ಸೊ ಈಗ ಅದರ ಡೈಮೆನ್ಷನ್ ಬರೆದ್ರೆ, ಡೈಮೆನ್ಷನ್ ಆಫ್ ಪವರ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು, ಸೊ ವರ್ಕ್ ಡನ್ ಆರ್ ಎನರ್ಜಿ ಡೈಮೆನ್ಷನ್ ಏನ್ ಬಂದಿತ್ತು ನಮ್ಗೆ, ಎಮ್ ಎಲ್ ಸ್ಕ್ವೇರ್ ಟಿ ಮೈನಸ್ 2 divided by t ಆಗತ್ತೆ, or this is going to give us power is equals to, one second, yeah, power is equals to m l square t minus 3 ಆಗತ್ತೆ. Hope it is clear. m l square t minus 3. Okay. Yeah. So any doubts, please raise your question here. Hope it is clear till here. Yes, okay, thank you. Hope you are following the session. If you have liked the session, if you understood the concepts, please put a like button, and if you want further contents, please subscribe to the channel as well. Okay, yeah. So going ahead to the next important concept, that is the principle of homogeneity of dimensions. This is one very important concept. One second, let me just come back here. So apart from this important definitions, whatever I have chosen, you can be asked few more, the dimensions of few more physical quantities. So don't worry, just take the basic formula of that and try to get the dimension. Okay, it should come by practice. You have to practice with for many physical quantities. Okay, so one more thing I can give here, that is, as I said here, energy means it can be any sort of energy is going to have the same dimension, like ml square t minus 2. It can be kinetic energy. Questionally in your exam they may ask you, write the dimension of kinetic energy. You no need to worry like, okay, it's something new quantity. No, it is a form of energy. Then the dimension of potential energy, the dimension of heat energy, or any form of energy they mention, they are going to have the same dimension, like work done or the general energy dimension. Okay, so that's how it is. And here I can also give you one more word. Sometimes the word stress is used. Okay, there's a slight difference in the meaning of stress and pressure, but for now, in terms of dimension, stress is also force by area, pressure is also force by area. Their dimensions are going to be same. Okay, hope it is clear. Okay, so here it is, to the next concept of principle of homogeneity of dimensions. So in the principle of homogeneity of dimensions, okay, so illi it's a very, it's not something new I am telling you. You all know it. You have done all this, till today, but we are putting it in a word like principle of homogeneity of dimension. So what is the meaning of it? So I'll tell you like there's a mass of 5 kg and there's a mass of something like 2 kg, and I tell you to add without any doubts or question. You say, okay, after adding I get 7 kg. Correct? Then I say there is a force of 5 Newton and there is some force of, let us say, some 15 Newton. Okay, and again I tell you to add, and without doubt you will say, okay, 20 Newton forces there. Now till here you had no doubt. Now I will say there is a time of 3 seconds. Okay, there is a time of 3 seconds and a mass of 5 kg. And I tell you to add. Do you add this? Am I allowed to add two different physical quantities which are having different units? Like one is time, one is mass. Can I add mass to time? Can someone respond? Yes, any response? Can you do that? Adding mass to time. That's not at all possible. Okay, so that is what is a principle of homogeneity. If I had to add or subtract any physical quantity, the thumb rule is that they should have same dimension. This is very, very, very important. Yes, Prarthana, thank you for your response. We cannot add time to mass, mass to force, force to something else. No, right? So if you are adding or subtraction, this is with respect to addition and subtraction. Multiplication and division you can do, no doubt in that. Okay, because you can imagine like displacement by time I can do, which will give me velocity. Distance by time I can do, which will give me speed, like that. With respect to multiplication and division, there is no problem at all. But when we are adding or subtracting, we should add or subtract the quantities which are having the same dimension. Okay, yeah. So if that is the situation, we can also put it in another way, that in any equation, if I take, the dimensions of all terms on either side of the equation must be same. Okay, if we are having some terms in an equation which are separated by plus or minus, I'm talking about the equations which are involving an equal signs, a plus or a minus sign, they should have the same dimension. Okay, dimension on left hand side must be same as the dimension on right hand side also. So this is called as principle of homogeneity. Okay, or homogeneity of dimension. So this is very important in order to the concept of applications of dimension. Okay, if you understood, please give me a thumbs up in the chat, and also you can like the video as well if you understood the concepts till now. Yes, any doubts? Okay, I hope there are no doubts. Okay, so going to the next concept, that is the applications of dimensional analysis. Okay, so what are the applications of dimensional analysis? The first one is to check the correctness of an equation. If I give you some equation, some physical equation, any formula you can take, I can check whether it is correct or wrong. That is called as dimensional consistency. Okay, we have to check for the dimensional consistency. The second application is to derive the relation between physical quantities of an equation. Okay, if you have to derive the relation between different physical quantities, certain formulas, okay, can be derived, which should not to involve any addition or subtraction terms. Okay, plus and minus symbol is agula only if it is with limited number of variables and it's in multiplication and division form, we can actually derive. So we will do one example for both, that is to check the dimensional consistency and also to derive the relation between different physical quantity. It's nothing but deriving a formula, you can say in a simpler word, to derive the formula. Okay, and the third one is to convert a unit of a physical quantity from one system of unit to other system. Okay, so if I have a unit like Newton or joules, which is an SI system, I have to convert it into CGS system, which we call like arcs. Okay, dyne, arcs. So if I want to convert unit from one system of unit to other, I can use the method of dimensional analysis. So equivalent unit ಏನು ಅಂತ ಬರುತ್ತೆ ನಮಗೆ. Okay, so let us learn one by one quickly. So first is to check the correctness of an equation. If any given equation is correct or not, I can check. That is called as dimensional consistency method. So please understand, if any equation, any physical equation, if it has to be correct, it should be dimensionally correct. In other words, the dimension of the quantity on either side must be same. The dimension on left hand side must be same as the dimension on the right hand side. And all the terms which are separated by plus and minus are also going to have, should have the same dimension. That is from your principle of homogeneity of dimension. Okay, is that clear? So that is how we check the correctness of an equation. So dimensional analysis ಅಥವಾ dimensional consistency ನೇ ಇಲ್ಲ ಅಂದ್ರೆ ಆ equation 100% wrong. Okay, but it doesn't mean that okay dimensional analysis ide andre need not to be always correct. Okay, dimensional consistency ide andre the equation need not to be correct, it is only dimensionally correct. But if any equation, if it has to be correct, it should be dimensionally consistent also. Okay, so one example tagolona what we are trying to understand here. Hope you all are all aware with this. V is equals to u plus at equation from your one dimensional motion. So where v is the final velocity, u is the initial velocity, a is the acceleration, t is the time. That's the usual notation, correct? So ಈಗ dimensional ಬರೆಯೋಣ. So our job is to check the dimension of left hand side must be same as the dimension of right hand side. That is one thing we had to check. Yes, Anvesha and Prarthana, right? Thanks for your response. Hope you're following too. Okay, and also we should see the terms which are separated by plus or minus, they should also have the same dimension. So first we have v here, so let me consider the dimension of v. So that is like velocity is like m0, there is no mass dependent, l t minus 1 we know that, right? lt minus 1, m0 lt minus 1, you can leave this m0 also, yeah, you can just write like lt minus 1 also, no problem. And then we have u, which is again initial velocity. So again I can say m0 l t minus 1. Then we have at, the dimension of a into t, that is acceleration into time. So acceleration m0 l t minus 2 into t, or this is going to give you m0 l t minus 1, t raised to minus 2 into t power 1, or t raised to minus 2 plus 1 will give you t raised to minus 1. So all the terms are going to have the dimension of m0 lt minus 1, right? So in bartade m0 lt minus 1 on the left hand side, and right hand also m0 lt minus 1, and this is correct equation in terms of dimension. Is that clear? Yes, Rakshita. Is that clear? Yeah. So going ahead to one more example. Check whether this equation is dimensionally correct. Okay. Yeah, what I will do is I'll take this, Anvesha, I'm responding to you. I'll take this, okay, as an example, and I'll try to explain the same concept. If you still get the doubt, we can go back to this previous slide and we can do this again. Okay, so here again what we should do, the dimension on left hand side must be same as the dimension on right hand side. Yes. So here first I'll consider half mv square. So half is a number, it has no dimension, correct? Numbers have no dimension. Half mv square dimension bariyana iga, half bit pidi. So m is capital M, I can say v square, v andre lt minus 1 whole square, can I write? Yes, or this is going to give you something like m l square t minus 2 is the dimension of mv square. Hope you agree to this. Yes or no? Similarly we can take mgh, okay. So again we'll write down the dimension. So m means capital M notation, g is nothing but acceleration due to gravity, okay. G is acceleration due to gravity, which can be written as lt minus 2, hope you agree. And h is the height here, okay. They are all standard notation. I know this equation, so I'm telling you, if it comes in the exam they will tell you what is g, what is h, what is v and all, okay. So h andre length matte, or this is going to give you something like m l square t minus 2. So again, did we get the same dimension? So here also ml square t minus 2, here also ml square t minus 2. So this is dimensionally correct, Okay, and I can tell you this half mv square is actually nothing but kinetic energy, and this mgh is something called as potential energy. Both are energy, so obviously their dimension will be same. This is something representing kinetic energy is converting into potential energy, which you will do in the later classes or later chapters. Okay, so let us not right now bother about the concept behind it. So just you take it as an equation, and whether it is dimensionally correct or not, you find it out. Okay, hope it is clear. Yes, Anvesha, now can you respond? Is it clear or not? If not, I will go back to the previous and I will explain it again. Quick response. Yes, hope you are there and watching the video. Do you want the previous explanation again? Hope it is understood, right, Anvesha? Artha aitalva? Artha agilla andre idan matte explain ಮಾಡ್ತೀನಿ. V is equals to U plus AT. Kindly quick response. Okay. Thanks for your response. We can go ahead. So one homework I can give. So after all these many, equation, one simple one I'll give. So take an equation like S is equals to ut plus half at square. Idu nimage gottiro equation. Again I am taking from motion in one dimension. So S andre displacement, U andre initial velocity, A andre acceleration, T is the time. So idara dimensional consistency check ಮಾಡಿ. ನಮಗೆ ಗೊತ್ತು ಈ ಈಕ್ವೇಶನ್ ಸರಿ ಇದೆ ಅಂತ, ಬಟ್ ಟ್ರೈ ಟು ಗೆಟ್ ದಿ ಡೈಮೆನ್ಷನಲ್ ಕನ್ಸಿಸ್ಟೆನ್ಸಿ. ಸೊ ಈ ತರ ಯಾವುದೇ ಈಕ್ವೇಶನ್ ಅನ್ನು ಕೊಡಬಹುದು ನಿಮಗೆ ಟೆಸ್ಟ್ ಅಲ್ಲಿ. ಚೆಕ್ ಫಾರ್ ದಿ ಡೈಮೆನ್ಷನಲ್ ಕನ್ಸಿಸ್ಟೆನ್ಸಿ. 3 mark question. Okay, yeah, 3 mark question it is. Hope we can go ahead to the next application of dimension. Here I just gave you one point which I have already mentioned. If an equation fails this consistency test, it is proved wrong. Dimensional consistency fail ಆಯ್ತು ಅಂದ್ರೆ ಆ equation 100% ಸರಿ ಇಲ್ಲ. Okay, but if it passes, it is not proved that it is right. Just dimensional consistency ಇದೆ ಅಂತ ಮಾತ್ರಕ್ಕೆ ಆ equation physically correct ಇರಬೇಕು ಅಂತ ಇಲ್ಲ. Okay, so a dimensionally correct equation need not be actually an exact equation, but a dimensionally wrong or inconsistent equation must be wrong. That is clear. Dimensionally wrong andre 100% wrong, but dimensionally correct andre it need not to be 100% right. Okay, it depends on the situation. Yes, I appreciate your for your effort of trying the dimensional previous problem, that is Chinni. So you are trying to get the dimension of half mv square problem. It's very much appreciated. Thanks for your involvement in the class. Hope you learned as well equally. Yeah. So moving ahead to the another application. So let's try to wind up with this question. Okay, that is deducing the relation or deriving an equation. ಇಲ್ಲಿ ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಿದೀವಿ, ದಟ್ ಇಸ್ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್, ಅಂಡ್ ಮೋಸ್ಟ್ ಪ್ರಾಬಲಿ ಒಂದು 70% ಟೈಮ್ ಇದೇ ಕ್ವೆಶನ್ ಕೇಳಿರ್ತಾರೆ ನಿಮಗೆ, ಇದರ್ ಇನ್ ಯೋರ್ ಮಂತ್ಲಿ ಟೆಸ್ಟ್ ಆರ್ ಯೋರ್ ಮಿಡ್ ಟರ್ಮ್ ಆರ್ ಮೇ ಬಿ ಇನ್ ಯೋರ್ ಫೈನಲ್ ಎಕ್ಸಾಮ್. ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್ ಯೂಶಲಿ ಕೇಳ್ತಾರೆ, ಅದು ಬಿಟ್ಟು ಇನ್ನೂ ಒಂದೆರಡು ಟ್ರೈ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ವಿಲ್ ಡೂ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್. ಲೆಟ್ ಅಸ್ ಟ್ರೈ ಟು obtain the expression for time period of a simple pendulum. So pendulum ಅಂದ್ರೆ ಏನಲ್ಲ, ಪೆಂಡ್ಯುಲಮ್ ಕ್ಲಾಕ್ ನೋಡಿದಿರಾ ಅರ್ಲಿಯರ್ ಡೇಸ್. ಸೊ ಏನಿರುತ್ತೆ, ಒಂದು ರಾಡ್ಗೆ ಒಂದು ಮೆಟಲ್ ಬಾಬ್ ಹಿಂಗೆ ಆಸಿಲೇಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಲೈಕ್, ಓಕೆ, ದರ್ ಇಸ್ ಎ ಸ್ಟ್ರಿಂಗ್ ಅಂಡ್ ವಿ ಅಟ್ಯಾಚ್ ಎ ಮೆಟಲ್ ಬಾಬ್ ಟು ಇಟ್ ಅಂಡ್ ಯು ಅಲೋ ಇಟ್ ಟು ಸ್ವಿಂಗ್. ಕರೆಕ್ಟ್, ಹಿಂಗೆ ಹಿಂಗೆ ಆಸಿಲೇಟ್ ಆಗ್ತಾ ಇರುತ್ತಲ್ವಾ. ಸೊ ದಟ್ ಈಸ್ ಯೋರ್ ಸಿಂಪಲ್ ಪೆಂಡ್ಯುಲಮ್. ಓಕೆ, ಸೊ ಈಗ ಅದರ ಟೈಮ್ ಪೀರಿಯಡ್ಗೆ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡಬೇಕು. ಓಕೆ, ಟೈಮ್ ಪೀರಿಯಡ್ಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂದ್ರೆ the time taken by the pendulum to complete its one motion. Like it starts from here, it goes here, comes back. What is the time taken? Okay, time for one oscillation, that is your time period. Okay, so time period or period of oscillation anta helbodu. Aduna capital T inda tagondidare. Okay, hope you are all following. Okay, so adu if you want to derive any equation, physical relation, okay, for the physical quantities. You should know on what are all the factors this parameter is going to depend. So ಇಲ್ಲಿ ನಾವೇನು ಅಸ್ಯೂಮ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇದು ಇದರ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ, ಓಕೆ, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಮಾಸ್ ಅಂದ್ರೆ ನಾವೇ ಅಸ್ಯೂಮ್ ಮಾಡ್ತಾ ಇದೀವಿ ಟೈಮ್ ಪೀರಿಯಡ್ ವಾಟ್ ಇಸ್ ದಿ ಮಾಸ್ ಆಫ್ ದಿಸ್ ಬಾಬ್ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. ಸೆಕೆಂಡ್ ಏನು, ಲೆಂತ್ ಆಫ್ ದಿ ಪೆಂಡ್ಯುಲಮ್, ಓಕೆ, ಸೊ ಎಷ್ಟು ಲೆಂತ್ ಇದೆ ಸಿಂಪಲ್ ಪೆಂಡ್ಯುಲಮ್ ಇನ್ ಬಾಬ್ ಇಂದು, the total, the string length, okay, so that is your length of the pendulum, and acceleration due to gravity, that is the acceleration by gravity, how much it is going to, how it is going to depend on these three parameters anta find out ಮಾಡಬೇಕು. Yeah, in upcoming class I'm going to start with motion in a straight line, okay, for today this chapter. The next class is for question discussion on this chapter. The next class will be for motion in a straight line, okay. Emmanuel, hope that is clear. So now what we do is we will say this time period is going to depend on mass raised to power some x, okay, that is how we do in terms of dimension, right? We assume it is going to depend on some physical parameter like, on the powers of some quantity like x, then length raised to y, okay, and then we have g raised to z. I have to find out on what power of length, on what power of mass, on what power of g it is going to depend, and there can be some constant which we will not know by the method of dimension, okay. So it is like time period is directly proportional to m raised to x, l raised to y, g raised to z anta ತಗೊಳ್ತೀವಿ, okay. So that is what it is. And now we will write down the dimensions. So that's all. So dimensional analysis problem andre first step dimension ಬರೆಯೋದು. So time period dimension ನಂಗೆ ಗೊತ್ತು, m0, l0, t raised to 1. K is some dimensionless constant which will keep as it is. And then we have m raised to x. So m andre ಏನು, or we can also leave this k in the when we are writing dimension, because it is understood we don't get the dimension of k, okay. So we don't get the value of k. K is a dimensionless constant, but we don't get the value of k by the method of dimension. We are only checking for the dimensional consistency. So then we have m raised to x. So I can say m l0 t0 raised to power x, then l raised to y, that is like again m0 l t0 raised to power y, and the dimension of g. So what is the dimension of g? G is nothing but acceleration due to gravity. So m0 l t minus 2. m0 l t minus 2. Okay. So we'll just raise to power z, that you are not supposed to leave. Okay. So what we get? m0 l0 t is equals to. So here we have m raised. I'll separate mass term separate, length term separate, time separate, okay. So here m raised to x is there, okay. Here m raised to 0y, not needed. M raised to 0 into z, 0, so not needed. Just m raised to x. Then l, here l raised to 0, here l raised to 1 into y will give you y, here 1 into z will give you z. So ಏನು ಬರುತ್ತೆ ನಿಮಗೆ, m raised to x, l raised to y plus z. And then we have time. So here t power 0, so no term. T power 0 into y 0 minus 2 into z. This is how you write down. Okay. I think I had to move to the next slide, because if I write here you may not see it right beyond this. Okay. So I'll just write in the next page. So what I'll do is I'll equate. So here m raised to 0 is there, m raised to x is there. So it's like if the bases are same, you can equate the power. Next ಇಲ್ಲಿ ಏನಿದೆ, ಒಂದೊಂದು ಕಲರ್ ತಗೊಳ್ತೀನಿ. So ಇಲ್ಲಿ l raised to 0 ಇದೆ, ಇಲ್ಲಿ l raised to y plus z ಇದೆ. And then what we have something like minus 2z ಇದೆ ಇಲ್ಲಿ. Hope you can see this. And here we have t power 1 ಅದು equate ಮಾಡೋಣ. So ಏನು ಮಾಡಬೇಕು, ಒಂದೊಂದನ್ನೇ equate ಮಾಡ್ತೀನಿ. So first is x equals to 0. By mass term, what I am getting, I'm getting x equals to 0. ಇದನ್ನ ಬರೆಯೋದು ಬೇಡ by mass term. I'm just writing it for your reference. Okay. Next, ಏನು ಬಂದಿದೆ ಇಲ್ಲಿ x equals to 0. Done. Next, y plus z is equals to L power 0 is there. So ಏನು ಬರುತ್ತೆ y plus z equals to L power ಏನು ಬಂದಿದೆ ಅಲ್ಲಿ 0ನೇ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಮೈನಸ್ 2z is equals to 1 ಅಂತ ಇದೆ. ಕರೆಕ್ಟಾ? t power 1 ಅದು. ಸೊ ಮೈನಸ್ 2z is equals to 1. ಕರೆಕ್ಟ್? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್. ಈಗ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. Okay, so this is one equation, this is one equation, this is one equation. So minus 2z is equals to 1 andre z is equals to minus of. If z is equals to minus of andre ee equation alli ಏನು ಬರುತ್ತೆ y minus of must be equal to 0, or this will give us y is equals to plus of. Correct? ಏನು ಬರುತ್ತೆ y is equals to plus of. So we got the values of x, y, z. X equals 0, y equals plus of, and z is equals to minus of. So ಈಗ time period equation observe ಮಾಡಿದ್ರೆ ಏನಿದೆ ನಮಗೆ, ಸೊ ಅಲ್ಲಿ x, y, z ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ x, y and z ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಸೊ ಏನು ಬರುತ್ತೆ ನಮಗೆ, ಟೈಮ್ ಪೀರಿಯಡ್ t is equals to some constant m raised to x andre 0, so you can leave that term. Andre time period is not going to depend on the mass. Okay, then L raised to y andre plus of, and g raised to z andre minus of, or this can also be written as k into, so you can ignore this m raised to 0, and ಇಲ್ಲಿ power half andre ಏನು ಅರ್ಥ, ಸ್ಕ್ವೇರ್ ರೂಟ್ ಅಲ್ವಾ, ಅದು ಸ್ಕ್ವೇರ್ ರೂಟ್ ನೋಟೇಷನ್ ಅಲ್ಲಿ ಬರೀಬಹುದು. ಮೈನಸ್ ಆಫ್ ಅಂದ್ರೆ ಡಿನಾಮಿನೇಟರ್, ಪ್ಲಸ್ ಆಫ್ ಅಂದ್ರೆ ನ್ಯೂಮರೇಟರ್ ಅಂತ. ಸೊ ಏನ್ ಬರುತ್ತೆ, yeah, so this k t is equals to k into square root of L by g. Okay, k into square root of L by g. So time period actual equation ಏನು ಬರೀತೀವಿ ಅಂದ್ರೆ t is equals to 2 pi root of L by g. ಆ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ 2 pi ಅದು, that should be obtained by experiment, that we can't get from our dimensional method. Okay, so this is how we use dimensional analysis to get the some equations, or to derive the relation between some physical quantities. Okay, is that clear? It's a quick revision. This is for 3 marks. Emmanuel, you can name yourself as Christina then. Christina Clara. Okay, no problem. So the application of dimensions, either to check the consistency or to derive the equations of a physical quantity, it is a 3-mark question. Okay, so hope you have understood the concept. Any doubt, please ask, and if you have liked this session, please give a thumbs up, and also you can subscribe to the channel for more content, and you can also follow our Telegram channel for the notes and more contents. Okay, so the description of Telegram link, the link, the Telegram channel link is provided in the description as well, so where you can get the notes for all these chapters. Okay, no doubts, I'll just end this session. Have a good day ahead. Take care.